Hello everyone, you're welcome to my channel. Have you ever wondered how pilots, sailors know exactly which direction to travel? They use something called bearing. And so in today's class, I will show you what bearing are and how to solve bearing questions step by step. Let's move on to this problem. But remember that bearings are usually measured in a clockwise direction from the north when it is written in the three-figure digit. This question says, town Q is 20 kilometers due north of P. That means town Q is directly north of P, just on top of it, north of P. The bearing of town R from Q is 140 degrees. If R is 8 kilometers from Q, calculate the bearing of R from P to the nearest degree. So the best thing to do here, or the first thing to do, is to read it again so that you have a better understanding of this. Town Q is 20 kilometers due north of P. That means for you to get the position Q, town Q, you start from a point P. You start from a point P. So where is point P? We have no idea. But we need to pick a point and call it point P because that's going to be our starting point. We know where Q is, that is after we've gotten P. So it's important we pick a point and let's call that point P. So I just want to draw this four cardinal and I'm going to call this my point P. This point here is point P. This is the north, the east, the south, and the west of P. Town Q is 20 kilometers due north of P. So that means town Q is just 20 kilometers northward. All you need to do is to extend this, go up northward for about 20 kilometers. So let's say this is my 20 kilometers. Remember, this is not done by construction. This is my 20 kilometers. So I will call this my point Q. This is my point Q. And this is 20 kilometers. The bearing of town R from Q. You can see the way it is progressing. The bearing of town R from Q. So you go to Q is 140 degrees. Now we're going to start measuring 140 degrees from Q. Remember I told you that this is measured in a clockwise direction from the north. So this is the north of Q. So I will start like this. All of this is 90. If I get back here, that would have been 180 degrees. Remember, but it says 140 degrees. So this is 90. I just need to add about 50 degrees to get to 140. Just a little. So I'm taking this to be my 140 degrees. Don't forget, I've been told that if R is 8 kilometers from Q, that means the position of R is somewhere on this line. R is somewhere on this line, The distance between Q and R is just 8 kilometers. That 8 kilometers must not be longer than this 20 kilometers. Of course, yes, it shouldn't be longer than this 20 kilometers. You expect that 8 kilometers will be shorter. So you don't just draw these as you like. No. We have to use our discretion. Remember that we are piloting something. We're trying to get a precise location. Alright, so I'm just going to draw this short and I will call this my R. I'm going to call this my R. This position is my R. 8 kilometers, label this 8 kilometers. This is position R. All of this is 140 degrees. And then I just need to join these together to R. And so I form my triangle. Alright. So that's it. I hope you understand the diagram. Okay. So what's now the question? Calculate the bearing of r from P to the nearest degree. Calculate the bearing of r from P to the nearest degree. The bearing of r from P. This is position P. Remember, this is P. This is P. Calculate the bearing of r from P. So you need to go to P and start measuring all of this to the line that join P and R together is the bearing of R from P. So what is this angle here? What is this angle? This angle here. Whatever that angle is, it represents the bearing of R from P. I hope you get that. Alright. So how do we find this angle? Let's look at all of the information given to us. What is this angle here? Can we find this angle? Yes. Earlier I told you that from here to this point here is 140, and then from here to this point here would have been 180 angles on a straight line. So the remaining portion here, this small part here, will be 180 minus 140, which is 40 degrees. 40 degrees. Another way you could find this 40 degrees is to recognize that all of this is 90 degrees, and then this small part here is 50. I just need to say 90 minus 50, and that gives me 40 degrees. So whichever way you want to look at it, you're still going to get this angle form at Q to be 40 degrees. Alright. How do we find this angle? Remember, this is what we're looking for. This angle here on P is the bearing of R from P. So I would suggest the first thing we do is to find this distance here. Let's find the distance PR. Find the distance PR. Okay, let me see if I can take this away, this diagram away from the question, so that I can adjust it. Can I really adjust it? Okay, yes, I think I can. And then I think I can make it bigger a little bit. Alright, so I said I would suggest let's find this value first. Value. This small side will be small q, remember. This will be small r. This will be p. Usually or conventionally, we call the opposite side to a particular angle the small letter of that angle. So if this is q, this opposite side will be q. If this side is r, then the side opposite to it will be small r. And then I will have this as small p. Did you get it now? Alright, so the first thing we need to do here, remember this is what we're looking for, this angle here, format P. So the first thing I would suggest we do is to find Q. Once we find the value of Q, that will give us some more information to be able to find this angle here. Because as it is here, I don't think there is any way we'll be able to find this angle P. This angle format this P. I don't think there's any way. If there's a way you can find this P, please leave it in the comment section without finding Q. Alright, so pay attention to this now. You know, someone else will say, oh, this angle here, I know it, this is 50 degrees. I agree with you, it is alternate to this angle here. But what about this angle here? What would this angle be? What is it going to be? You can't say it's 45, right? Of course, I know you can assume that. Alright, so let me take that out. Let's take it out. If you have not subscribed to my channel, please click on the subscribe button, click on the follow button, like and share. Please like and share. This is bearing made simple. So let's find the value of Q. To find the value of Q, we're going to use the cosine rule. I told you about cosine rule in my previous class. So it's going to be the square of Q. The square of the side you're looking for will be equal to the sum of the squares of the other two sides, just like a Pythagoras theorem, but the addition to this will be minus 2rp cos Q. So let's do this quickly. I have Q square equals to R 20 square plus 8 square minus 2 times 20 times 8 cos 40 degrees. I hope we've not made any error. Alright. So Q square equals to, this is 400 plus 64 minus 20 times 2 times 8 is 320 and then you have times cos 40. Cos 40 is 0.7660. So q square, this will be 464 minus 320 times 0.7660, and that's 245.12. So now subtract this. 464 minus 245.12, and that is 218.88, and then you find the square root of this. 218.88, square root of 218.88 is 14.79 kilometers. 14.79 kilometers, and that's the value of this q. Now that we found this as 14.79 kilometers, it makes it much more easier for us to find this bearing. Remember, we're interested in finding the bearing of r from P, and that's this angle here, that's this angle P here, this angle P inside here. So to find that bearing, I'm going to use the sine rule. The sine rule is faster. Yeah, I could also use the cosine rule to find P, but the sine rule is faster. So this is what the sine rule says. Sine P, the ratio of the sine of an angle to the opposite side, is constant. That means if I pick this also, the ratio of sine Q over Q will be equal to the ratio of sine P over P. The ratio of the sine of an angle to the opposite sides are equal, they are constant. So sine P over P, P is 8 kilometers, equals to sine Q, Q is 40, divided by sine Q, that is 14.79. So cross multiply this. You have 14.79 sine P equals to 8 sine 40. And so sine P equals to 8 times sine 40. Sine 40 would give you 0.62, 0.64, 28. All of these divided by 14.79. So sine P is equals to, you're multiplying now, 8 times 0.6428 divided by 14.79, 0.3477. So at this point you need to find angle P, and then you can just simply use the calculator. Sine inverse of 0.3477, and that gives you 20.35. Okay, 20.3, let me use this, 20.347 degrees, and that's angle P, which is the bearing of R from P, and that's 20.347. Now we have been told to approximate this. It says to the nearest degree. So to the nearest degree, this is to the nearest degree. To the nearest degree, that's 20 degrees. To the nearest degree. I hope you got that. Please click on the subscribe button. If you have not done that, click on the subscribe button. Now let's pay attention to the B part of this. The B part of this is a little bit crazy, but pay attention to it. It says how far north of P R is. Correct to two significant figures. How far north of P. If you don't get the diagram correctly, then you won't be able to answer this correctly. alpha naught of P. So let's just go to the diagram again. Alpha naught of P R is. That means you need to go to P and then northward, just continue to go northward of P, continue to go northward of P until you realize that you've gotten to where R is. R is somewhere here. This is where R is. This is where R is. So what is that distance north of P to where R is? Again, alpha naught of P. You go to P and you start the journey northward until you get to a position where you know that R is. So R is somewhere here. R is somewhere here on this line. And this is going to be at 90 degrees. This line is going to be at 90 degrees to this point. So what is that distance northward? What is that distance? This is the distance we are looking for. From this position P to this point here. This distance here is what we are looking for. What is that distance? Alpha naught of P. So don't be distracted with all that you have on the diagram. Alpha naught of P. So I want to call this, let the distance be, let me use H. Let the distance be H. Let me call this H. If I bring this out, if I bring this diagram out, you realize that I have something like this. I would have something like this. I would have this. And then I would have something like this. Good. I would have something like this. And so this is that my P. This is alpha naught. This is R. This is the distance we're looking for. Remember, I just got this as 20 point something. This distance here is 14.79. And so this is at 90 degrees. I'm looking for the value of H, which is northward of P to where R is. The distance northward. So I have a right angle triangle. And so my focus will be on using the SOHCAHTOA, to find the value of H. So how do I find the value of H? What's that angle again? 20.347. 20.347. This is going to be my opposite, the hypotenuse, and this H is the adjacent. So what link? I have the value of the hypotenuse and I'm interested in the adjacent. So I'm going to use cos, right? Cos, yes. Cos is adjacent over hypotenuse. So I'm going to have this as, remember that the distance northward is H. So B, so I have cos 20.347 is equals to the adjacent over hypotenuse, which is 14.79. I hope I got that value. Okay. So if you cross multiply this, you have H equals to 14.79 times cos 20.347 will give you 0.9376. So if you multiply these two together, 14.79 times 0.9376, we have 13.867 kilometers. And that's the distance northward. We have been told to approximate to how many significant figures? 2 significant figures. Alright, so we start counting from the very first non-zero digit, 1, 2. The next number here is more than 5. So round this up, we say 14 kilometers to 2 significant figures. I hope this was helpful. Please share and like. Leave your comments below.